Warm greetings for all. We will start the webinar within 5 minutes. Meanwhile, if my screen is visible and my audio is clear, please type us in the chat box. Once again, good evening to all. I am Gokul Krishnan, Research and Development Head of ISTE VIT 2022. Today we will be seeing a webinar about innovating with IoT. Before wasting time, we can move on to the agenda. So first we will see what is IoT, like overview gist of IoT and the definition of IoT and the practical explanation of IoT in the overview. Next we will move on to the devices which we are going to use in IoT, and we will be building a project too. So we will be explaining the configurations of the MCUs that we are going to use in today's project, and we will move on to the live demo of the project that we will be that you will be making with us, and you can just make it later also. It will be very much useful, and you can understand what is IoT practically using these things. So this is the agenda, and entire webinar will be following this agenda. So first we will dig on to overview of the entire topic. What is IoT? So before explaining me what is IoT, we should know the full form of IoT. IoT, the full form of IoT is Internet of Things. But what does that mean? What is like Internet of Things? It doesn't sound good, right? It doesn't give you the explanation Internet of Things. It just gives some things or internet. It doesn't say what is internet, what is things, what is Internet of Things. Don't worry, we will move on to the simple practical explanation of this Internet of Things. To explain it very simply and to make it in much simpler terms, it is a universe of devices with internet connectivity. Everyone knows what is the internet. Internet is nothing but the communication between the devices. Communication between the devices within a local network is an intranet. Communication between the one device which is in one city and another device which is in another city or another country or another continent or outside the earth also can be called as internet. So this is the difference between the intranet and the internet. So now we know what is internet. Internet is nothing but the communication between the devices. So what is IoT then? Universe of devices with internet connection. So any device which has an internet connection can be called as an IoT, but not specifically. Take a laptop or a computer or a desktop or a mobile phone. It has internet connection, but it is not called as an IoT technically. IoT devices are specially made for special purposes. Let's say example, your laptop can perform million tasks per second. You can send a WhatsApp message, you can browse Facebook, you can browse Instagram, you can browse LinkedIn, you can play a game, you can stream OBS, you can make a PPT, you can give a presentation, you can make a video call, you can make audio call at the same time. These things can happen at the same time at a parallel processes. At the same time you can do multiple processes. So this is more kind of a general purpose mission. But talking about IoT devices, it is not a general purpose mission. That device or a mission is made for particular purposes. So again, I am recollecting the definition and practical explanation of IoT. IoT, in simpler terms, we can say as universe of devices with internet connectivity. It is a separate universe, or it is a part of universe of internet, the devices which has internet connectivity. Okay, we understood what is IoT, but what is things in the abbreviation of IoT, Internet of Things, right? So what is things there? Things is nothing but the device which I said you earlier. Any device, embedded device, or any device in the IoT sector which will be having a sensor or a similar kind of communication to the MCU. MCU is nothing but the microcontroller unit, which is designed for a specific application, and it should have an internet connectivity. Why it should have an internet connectivity? Without internet connectivity, we cannot say it is an IoT device. So that is obvious from the definition. But what is the use of it? What is the end product of it? Let's say example, take a processor or take a microcontroller. With just a microcontroller, we cannot do anything. Now we will be interfacing a sensor. Let's say today we are going to use an weather temperature sensor. Okay. Let's say now we are interfacing the temperature sensor with the microcontroller. Now the microcontroller and the temperature sensor can communicate. Temperature sensor can give inputs to the microcontroller, and we can read outputs from the microcontroller through our computer. That's fine. That's good. Okay, we can read what is the temperature of the room or of the city in your computer. But what if there is a friend of mine who is living 200 or 500 or 5000 kilometers away from me and wants to know the temperature of my city instantly without asking me personally, like without calling me or without texting me? So what we can do? Now here the IoT things play. With the microcontroller unit, with the temperature sensor, we will be connecting the internet also. So now there are three things here. One is the brain, microcontroller unit. Next thing is a node, which is called as a sensor, and another thing is internet connectivity for that microcontroller unit. These three things make the things in IoT. Okay, things is nothing but a device. So to be more specific, it should be called as an embedded device. Device is just a generic term. So this thing should be called as an embedded device. Why it should be called an embedded device? Because embedded device and this device is made for particular purpose. So the example which I gave you now is just the microcontroller just reads the data from the temperature sensor and it publishes to the internet. It does not use to play game, it does not use to call, it does not use to browse Instagram, it does not do anything with the internet. Only thing it does is publishing the temperature sensors to the cloud. So that's why we call it as an embedded device. So here you can ask a question, what is this, like even our computers can publish the data to the cloud servers. Why can't you interface a temperature sensor directly to your laptop or a computer or desktop or a mobile phone, and I can publish it to the cloud, right? So here the problem comes. The problem is you cannot have your computers switch on for 24/7. That's the first thing. And the second thing is energy consumption of the desktop or a laptop. It's a huge in the sense, for a desktop it's around 450 watts to 650 watts. It's not the small thing. But when you compare a power consumption of a desktop or a laptop with an IoT device or an embedded device, to be more specific, when you compare a power consumption of a desktop to a normal embedded device, the desktop power consumption will be around 500 watts, and the power consumption of the embedded device, to be more specific here, NodeMCU, let's take an example of NodeMCU, it consumes around maximum 80 milliwatts. So here you can check the difference. So it consumes around 80 milliamperes of current. So if we do some math, power is equal to voltage into current, it will consume around 0.3 watts. The embedded device is consuming 0.3 watts, and the desktop, a general purpose machine, is consuming around 500 watts. So this is why we are moving to the embedded device, and we are not using any general purpose machines to in the application of IoT sectors, in the things. So in the slide you can see at the left side there are many devices. The first device can be a light or a temperature sensor or a temperature display. The second top right can be an IoT switch. The center thing can be same as an IoT switch. The left thing can, you guys know, that's a Google Nest. The bottom thing is it may be an IoT enabled camera, and the right thing may be a IoT enabled biometric system or IoT enabled remote control system. What these devices are doing in the network, let me explain. The first device, the number 72, which displays the number 72, can be display for a temperature value. So it can be displaying the temperature of a New York in the Vellore city. Imagine these devices are in the Vellore city, in the VIT university, in the VIT college. This number 72 degree Fahrenheit or Celsius, let's take an theoretical case, not a practical case. So this 72 degree Celsius or Fahrenheit can be a reading from the IoT device from US or Canada or some part of the world. The next thing is an IoT enabled switch. Using my mobile phone, I can switch on any devices wherever, irrespective of the place, wherever in the world. Take my mobile, open the app, just click something in the application, and the switch in your home will get turned on. We can connect any appliance to the switch. It can be a light, it can be a fan, it can be an air conditioner too, it can be a mobile charger, it can be a washing machine, anything. And you guys know Google Nest, it's also an IoT enabled device. Just you can speak, hey Google, can you turn on the lights? Like that, it will turn on the lights. So that's the thing. And IoT enabled camera, like I can set up a camera at US and I can connect it to the server, and I can watch what's happening in the US from the Vellore. I think I gave a good amount of explanation for what is things in the Internet of Things. So these are some practical examples around you, which you can see the IoT devices in the daily basis. Let's move on. So in this webinar, I will be using a component or a device called NodeMCU. What is this NodeMCU? Uh, it can be called as an IoT enabled device, an internet enabled device, which is used to interface different kind of sensors with it and publish its values to the internet. It is a microcontroller. We can say it is a microcontroller which has an SoC in it. SoC is nothing but an system on chip, where system on chip means the microcontroller or microprocessor, RAM, memory, everything will be embedded to a single chip. That's called as a system on chip. This NodeMCU is not a microcontroller board, it is a development board. So this development board contains an ESP8266 SoC with it and breakout pins to connect several sensors, to connect several things, and we can interface it with several other data or sensors or anything. And it has an USB micro USB port, also micro USB female port. We can program using that, or else we can read the data using that pin. And there are two switches, one is flash and one is reset. We will be using reset switch a lot, and there are some pins. So why you need to go for this device? The first reason is because of its low cost. I would not I'm not interested to say it is low cost. I am interested to say it is the lowest cost. See the English here, it is the lowest cost, because this thing you can buy it for just 210 rupees in the market. Starting price just 210 rupees. You can buy IoT device, IoT development kit for just 210 rupees. That's what it becomes that's why NodeMCU is much popular in the world, because of its cost. The second thing is easy to program. The thing, like when you take an Arduino, or let's talk about a microcontroller. For example, let me take an 8051 microcontroller. So you may not know what is an 8051. So 8051 is a microcontroller which is also a cheaper. The cost of the 8051 microcontroller lies around rupees 60. So you may think, why can't we go for 60 rupees microcontroller instead of NodeMCU? So I will say 8051 is just a microcontroller. It does not have a development kit. If you want to develop a development kit for it, it will cost around 1000 rupees or 1200 rupees, like that. So why so? The reason is we cannot directly program the 8051 microcontrollers using our computers or desktops. It requires a JTAG or some kind of circuits which converts UART signals to the microcontroller signals, like we say TTL, transistor logic signals, and we need several circuits. We need a power circuit to power the thing. We need voltage regulators to make the 8051 power up. We need several things, right? So that's why it's not advisable for the beginner to go and make 8051. And again, we need Wi-Fi modules or Wi-Fi chips to kind of interface it with 8051. It makes our job hard. Of course, as an electrical or electronic engineer, you should know how to program or how to interface 8051. But as a beginner, you can begin with NodeMCU. Not even electrical and electronic student, even a computer science student, even an arts and science student can use this NodeMCU. That's how. That's why I am highlighting in this term. Very easy to program. There is no need to have any prerequisite knowledge to program this. As I said before, it's an IoT enabled chip. You have the Wi-Fi sensor inbuilt in the NodeMCU. You can see here it's written as Wi-Fi. The Wi-Fi official symbol of Wi-Fi is here. So it's an IoT enabled chip. You can directly connect to the internet using this chip. As I said before in the things definition, this NodeMCU consumes around 76 or 80 milliwatts at 3.3 at 5 volts, because your adapters, you will be using USB cable or USB adapters from your laptop or from the wall charge adapters or travel adapters, which will give you the output voltage around 5 volts. So when you power it with 5 volts, and at max it will consume around 80 milliamperes, the power will be around 0.3 watts, something like that. Okay, 0.4 watts or 0.45 watts or 0.3 watts, something like that. So you can see that it's very low. The power consumption is not even close to 1 watt. It's just 0.3 to 0.5 watts in between these two things. So that's what it makes more reliable, more attractive for everyone to go for this NodeMCU. The next device which we'll be using in our session is DST11. What is this DST11? What is this blue color watch chip with 3 pins? This is nothing. This is just a sensor. This sensor gives us two values. One is temperature, and next thing is humidity. You guys know what is the temperature and humidity, right? So we cannot measure directly. We cannot measure directly with our phones. Does not have temperature sensor, or I mean environmental temperature sensor, or your laptops doesn't have environmental temperature sensors to measure the surrounding temperature of the room or of the city, right? So that's why we use DST11 sensor. And so how this DST11 sensor works? This is a digital sensor. First of all, we should know this is not an analog sensor. This is a digital sensor. So what is the difference between a digital sensor and an analog sensor? Analog sensor will give you values continuously. Like say, if we are powering the sensor with 0 to 5 volts, analog sensor can give you values like 0.3 volts or 1.3 volts or 1.7 volts or 4.8 volts or 4.8567 volts, anything kind of analog signals. It's a continuous waveform. Take a sine wave. Sine wave is an analog signal. You can have an infinite number of x-axis terms in the sine wave, right? You can have infinite number of amplitudes in the sine wave. So that can be set as a continuous waveform, and that is called as an analog signal. Let's now explore the digital signal. So what is digital signal? Digital signals will have just two values, either 0 or 1. You guys already know, you would have learned in the 12th computer science or 12th mathematics also. In discrete mathematics, we know only true or false. So true means 1, false means 0. Computer can't understand the analog values. It can understand only power on or power off. It is a binary machine. Binary means 2, 0 or 1. So in the digital case, 5 volt means 5 volt means 1 and 0 volts means 0. And in some microcontrollers, they use 3.3 volts as 1 and 0 volts as 0. So the analog sensors will give you a continuous reading, a continuous voltage forms, and a digital sensors will give you an waveform, like with a starting bit, ending bit, and in between the message bit signals. In this DST11 sensor, the message bit ranges to 40 bits. So these 40 bits will have information about the room's temperature or the room's humidity. Why to go for this sensor? Why to go for this DST11 sensor? It can measure both temperature and humidity. This is the one of the reason. And the main reason is libraries are already available. If you use an analog sensor, we can just do some math and we can just calculate, do calibration. But for digital sensors, if there are no libraries available in the open source or in the internet, you need to manually write the code for digital communication. I said now, first we need to give a start bit, then send a message signal and receive a checksum and stop bit. So you need to write manually everything if it is a digital sensor, if the libraries are not available in the open source. But in our case, DHT11 library is available as an open source in GitHub and in Arduino libraries too. I will be showing how to download those things. It makes our work much easier. As I said, it is a digital sensor, of course, and it's very simple to interface. There is no much complications in the wire, or there is no need to use breadboards, or there is no need to use PCBs to interface this sensor with the microcontrollers. I will be showing a live demo of connection, and you can feel how easy to use this. The last thing and the main thing we will be seeing in our webinar is the ThingSpeak platform. ThingSpeak platform is done by the MathWorks. I think you all guys know what is MathWorks. Rather than telling MathWorks, I can tell it as a MATLAB. MathWorks is a company whose one of the product is MATLAB. MATLAB is so popular. So the company who created the MATLAB created the same ThingSpeak platform also. What is this ThingSpeak platform? ThingSpeak platform is an IoT data analytics platform where we can publish and receive the data very easily. Today I will be showing how to use these things. So what is the advantage to go with the ThingSpeak platform? It is powered by MATLAB. So I think you guys know what is MATLAB. MATLAB is the most powerful software for data analytics, for mathematics, for digital simulations, for everything. MATLAB is the most powerful tool, a mathematical tool for analyzing the data, or for everything, for simulation and everything. And of course the VIT students have license for MATLAB, and they have license for ThingSpeak too. It's just a great thing. We can use our license to interface with ThingSpeak and MATLAB. The next advantage of going to ThingSpeak is fast and instant. You can get the outputs instantly after publishing. It's just a great. You can do big data analytics using ThingSpeak. You no need to get the values, go to MATLAB, plot the graph, analyze the value. No, you no need to do anything like that. Just publish the value to the ThingSpeak server. It will automatically plot you the values. I will show that. And it uses MQTT. So what is this MQTT? MQTT is nothing but it's a kind of a protocol which is commonly used in Internet of Things. MQTT stands for Message Queue Telemetry Transport. So how this MQTT works is, it has published subscriber network. Like let's say there is a topic called temperature. So this topic temperature can be subscribed by many modules. Now this topic temperature is created by NodeMCU, or created in the ThingSpeak server, and the ThingSpeak server itself is a subscriber of this topic, and our NodeMCU is also a subscriber of this topic. So client, we can call it as a client. So our NodeMCU client can send the data to the ThingSpeak server, and this ThingSpeak server can read the data which is obtained from the NodeMCU. So this is how the MQTT works, and Facebook initially used in their messengers this protocol, MQTT protocol. This is just for the information. Till now, you guys have any doubt? If you have any doubts, just let me know in the chat box. You can feel free to chat. Like if you have any basic doubts also, you can ask. Okay, let's move on. The next, as per the agenda, the next thing we will be seeing is configuration of the devices. First, in the configuration, we will see the pin diagram of the NodeMCU. So this is the clipboard of the NodeMCU, which has the pin diagram explained here. So you can see there are several pins at the left and right side of the NodeMCU. The main thing here you should notice the digital pins, starting from D0, D1, D2, D3, D4, D5, several other things, and 3.3 volts. It does not have 5 volt output pin. It only has 3.3 volt output pin, and several grounds. There are 4 grounds here, and 3.3 volt pin, and it has an one analog input pin, and you can see there are several digital pins here. You can count it later. It has a reset pin too. So what is this reset? Why is this reset pin is used for? Is when the code is running, you no need to disconnect and connect it again to restart this device, to restart the NodeMCU. You can just press the reset button to restart the device, and splash button is not widely used. It is used while flashing the bootloader, some kind of things like that. So for our case, we will not be using this flash. We will be using this reset button. So this is the outline of the pin diagram. And in the previous slide you saw there is a D0, D1, D2, D3 ports, right? But Arduino cannot understand those things. So Arduino can understand only GPIO pins. What is this GPIO? GPIO is nothing but the general purpose input output pins. So here you can see A0 pin is mapped to A0 in Arduino. D0 pin is mapped to GPIO 16, that is 16. You need to give pin number in Arduino as 16. So D1 to 5, D2 to 4, D3, if you are connecting the data output of the sensor, you should connect D3 to 0. You should connect the sensor to D3 and you should code in the Arduino IDE as pin number as 0 if you are using D3. Now we will move on to the pin diagram of the DST11 sensor. As you can see, there are 3 pins. The first pin is VCC, where we will be supplying 3.3 volts. The center pin is data pin, where we will be reading output, and we will be connecting this data pin to D3 pin of the NodeMCU. And the last pin is ground pin, a common pin which is connected to the ground of the NodeMCU. So these are the connections. As I said, VCC will be connected to 3.3 volts, ground will be connected to the ground of the NodeMCU, and data pin will be connected to D3 of the NodeMCU. Before wasting the time, we will move on to the live demo of the session. So now we will be making a project where now I am in the VIT University in the hostel room. So we will be reading the temperature of the hostel room, and we will be publishing it to the cloud, ThingSpeak cloud, and you can read the data from anywhere in the world. So we will move on to the thing. So I hope now my desktop screen is visible. Before starting, you need to download Arduino IDE. So for that, just type Arduino in the Google and go for software. Here you can see Arduino IDE, and there are several versions based on your operating system. You can choose. You can download a zip file, or if you are using Linux, if you are using Linux, you can download the Linux things. And if you Windows, just click Windows and it will download the MSA or exe file. Just install it. If you are interested, you can contribute or just click just download. So it will be downloading. I already downloaded, so I am not downloading it again. After download completed, you just click next install and open the Arduino IDE. So I am now opening the Arduino IDE. So now the Arduino IDE is opened. Now here you can see for you it will be the new screen with void setup and void loop as an initial code typed pre-built. So I will just go through the IDE once. Here is the file. Here you can set the preference, font size, everything you can change, and edit, you can just edit. You can increase the font size here too. Sketches used to include some libraries. I will be going through this. Tools, you can select the board, which board you are using and which baud rate you are going to publish the program or flashing the program, and if you want any help you can just go through it. So now we will be using the NodeMCU, right? So to set up the NodeMCU, we need to have the board, what to say, like the board link. We need to download the board file to the Arduino IDE. Since this is an Arduino IDE, it does not come with an NodeMCU board file. So for that, first click preference, file, preference, and this is the link you need to add here. For you it will be blank like this. For you it will be blank like this. Now you need to copy the link, and the link will be in the description as well as it will be shared in the chat box too. Copy it, place it in the additional board manager URLs like this. After placing it, just click OK. The next thing you should do is go to tools, go to boards, and go to board this ESP8266 will not be visible for you. Go to tools, go to board, go to board manager, and here you can see it will take some time to load. Just be patient. Okay, now it's loaded. Now at the top you can search for ESP8266 and press enter. You can see there is an official board manager for our ESP8266 NodeMCU. Just click this and install it. I already installed. Here it shows it's already installed. So you can install new version. I am using 2.74. There is a version 3.02. Of course you can install the new version. Install it. After installing it, the next thing you should do is again click tools. Just a second, I just closed it, so it needs time to configure it. Okay, now click tools, now click board, and now you can see this ESP8266 board. Here you need to select NodeMCU version 1.0 because in the market this one is available widely. So click NodeMCU 1.0 after successful installation of the ESP8266 board manager. Now you all ready to go. Now we will type the code. So what is void setup? If you type anything in the void setup, it will run just at initially. It will run at the first. If you type anything in the void loop, it will be looping itself. It will be running continuously till the NodeMCU receives the power. So now we will move on to the program. First we will read the temperature values locally, and then we can publish the same values to the cloud. To do that, I need to download the two libraries which I said before, the DST11. So go to sketch, include library, click manage libraries. It will again take some time. Just be patient. It should complete the downloading process of library index. We should wait for it. Okay, done. So here you need to first search for DHT. Just type DHT and press enter. there are many libraries available here, so that's why it is taking much time to load. Just wait for it. It did not complete the search. Okay, it completed the search. As you can see, there are n number of libraries available here. So which one to install? Of like mostly everything, if you install, it will be working fine. But to be more specific, you can install uh, the DST sensor library by Adafruit. Adafruit is also an open source company, and it's a very good company. It makes very uh, more reliable library products, library packages. So after finding the DST sensor library by Adafruit, install this. I already installed it. Okay, now this thing will work for Arduino, but you need to make it work for NodeMCU, right? So for that you need to again search for Adafruit. Just type Adafruit sensor. We will be sharing a GitHub link for these libraries as well, and I will be showing you how to download. After downloading the zip file of that GitHub file, you can just directly import instead of searching here. Okay, it's searching. We have already posted the GitHub links, so you can just download and make it a zip. Automatically it will download as a zip file. I will be showing how to do interface it with here, and you can see there are again several Adafruit sensor library. You need to find Adafruit unified sensor. That is the library we are going to see here. So instead of going here, just type Adafruit unified sensor. Or else, as I said, you can directly download the zip file, and you can directly burn the zip file in the Arduino IDE. Okay, at the last you can find Adafruit unified sensor. So this library is used to program the Arduino programs inside the NodeMCU, because Arduino is an AVR platform where DST11 is specially designed for Arduino AVR platforms. So now we require this DST to use in NodeMCU, right? So for that we will be using this Adafruit unified sensor library. As its name says, it unifies the sensors, unifies all the sensors, and it makes work in the NodeMCU as well. Install this too. If you're downloading directly from the GitHub, just click Sketch, include library, add.zip file. Just click add.zip file and just browse where your zip file downloader. Double click, and the library will be directly added to the code. Now we will start to code. Before starting here, you need to include libraries for the reading of the sensor. So for that you can manually type #include dst11.h, something like that, or else you can do sketch include library. Just go down. There will be a DHT sensor library. Just click it. It will automatically get added. So now we successfully added the libraries. The next thing we should do is we need to call this library and declare an object. So I am declaring DST object, and this DST object takes two arguments. The first argument is DST pin, that is I am going to connect the DST sensor to the pin number 0. in the NodeMCU it is pin number D3. You can refer the tabular column which I showed you previously, and the PPT will be shared to you also. You can refer there too. And I am connecting DHT11 sensor. There are several like DHT22 sensor is also much popular. So for now I am connecting DHT11 sensor. So I successfully declare an object. In the void setup, I will be calling the serial dot be begin 9600. So what does this do? So we want to print the serial. We want to print the temperature values in this monitor, right? In our screen monitor. So for that, we need to first call the serial port of the serial communication between the Arduino or between the NodeMCU and the computer. So for that, first we need to start the communication. For that, we are giving serial.begin. What is this 9600? So this is called as an baud rate. 9600 called as an baud rate. So what is a baud rate? Baud rate is nothing but the communication speed. Like 9600 tells you it can transmit 9600 bits per second. So that is the thing. So in the void loop, we will be giving code like declare float t is equal to dht dot read temperature. As you can see, the wordings will be automatically turned to orange if it's correct, because these objects or these methods are already defined in the DHT's library. We are just calling it using the objects. Don't forget to give it a semicolon, and to read the humidity again get a float h is equal to dht dot read humidity. It does not take any arguments. Now for printing the value, just call serial dot print, give a string like temperature give colon, and I am just copying it. Here I will be printing here. I will be giving the argument as t, and again I will be using serial.println, because it should, after this line it should be in the new line. So for this argument I will give as a Celsius, because this sensor returns the thing as returns the temperature in the Celsius. I will be copying these three lines and pasting it here for the humidity reading. Humidity is measured in the percentage. So this is our code. Our code is done. So now I will be showing you how to make the connections. So I hope now my camera is visible to you. So here you can see this is the NodeMCU module. Here you can see that Wi-Fi ESP8266 switch and the USB port and the digital pins here. Here you can see the DHT11 sensor too. See, it has a sensor and 3 pins. So I need to connect these 3 pins to the NodeMCU, right? So for that I will be using female to female jumper wires, because these two things have header pins. So I will be connecting this thing. So the first thing, I will be connecting wires to these things. So connect it here. Take another jumper wire, connect it. So now we connected all three jumper wires to the sensor. Now we need to connect this to NodeMCU. The first pin of the, in this sensor, the first pin of the DST11 is ground. So I will be taking this first pin and I will be connecting it to the ground of the NodeMCU. Here it is written as G. And the center pin of this sensor is the data pin. I will be connecting the data pin as we discussed to the D3. And the fourth pin here, the third pin here is the power pin, VCC pin. As you can see, I will be connecting VCC pin to the 3 volt input. Now the connections are done. Now I will be just connecting a USB cable here to the NodeMCU, and you can see the LED in the DST11. Some sensors have LED also, some sensors may not have LED. Now it started to power. Now we will switch on to the IDE. I hope my desktop screen is visible now. So now select tools, just check once the board is selected as NodeMCU. Yeah. Now in the port you just select the port whichever is available. In my case it is COM7 port. So COM7 port is selected. Now before uploading it, compile the, verify the file, verify or compile, save it anywhere, save it. Okay, we got some errors. We need to look at what errors we got. So error expected, comma, or before void setup. So we did not have a semicolon before void setup. So that's the error. Again verify it. So it takes some time to compile it. We are running short of the time. We will be finishing it faster. Okay, the compiling has been done. There are no errors. Now you can directly upload the code to the NodeMCU microcontroller using this button. It will again compile it, but this time it will compile it somewhat faster than previous time because it's already compiled. So now it's uploading. You can see the board is connecting and uploading percentage is 15, 23 percentage, 30 percentage. So it is now writing the flash memory in the Arduino to the new program. Now the hard resetting is done by the software. Now here you can see the serial monitor icon here. Just click it, and now you can see the temperature values and the humidity values printed on the screen. So these values are printed at very fast rate, right? Because we did not give delay here. So to print it slowly, to print it every 5 seconds or 3 seconds, you need to give a delay here. So here you can see the temperature and humidity sensors values. So this is how we need to get the data from the Arduino. Now this is not our goal. Our goal is to publish this data to the cloud and to read it graphically, right? So for that, now we will start writing the code. We will use the same code itself to write those things. I will just disconnect the NodeMCU. Whenever it's not in the use, just disconnect it. Now we will be modifying the same code to make it published. Before that, we will now set up the ThingSpeak cloud server. Just go to Google, type ThingSpeak. Go for ThingSpeak IoT Analytics. As I said before, VIT students have license for this, so you can just directly click the accounting. You can directly sign in using the MATLAB email ID. After the first sign in, you can see this window. So now click on the new channel and give it a name as IoT project 1, and you can give a description as well. We will be measuring two values, right? One is temperature and another thing is humidity. So click these two values and name it as temperature and humidity. And if you want, you can just explore these metadata tags, links to external type, link to GitHub. You can explore these things. For now, we just click save channel. Okay, our channel is successfully built. So this is what needed to set up in the cloud server. If you want to add widgets, example, add widgets, click numeric display, click next. Enter the name. I am entering temperature, and I want to read field 1 because I am going to give field 1 as a temperature, and measurement units is Celsius. Update every 15 seconds. I'm going to make it as 5 seconds. Okay, it requires minimum 50 seconds to update it. ThingSpeak cloud. So create it. So now here you can see the temperature numeric value. Field value is unavailable because we did not publish anything as of now. So I will be explaining how to get API keys. Before that, we will move on to the code. So I will be directly explaining you the code. The code will be shared in the GitHub, or it will be shared in the YouTube description to the GitHub repo. You can just directly get the code from there. So as I said before, these two things are used to these two libraries are used to get the temperature readings from the sensor DST11, and this hash include ESP826655.h is used to connect the NodeMCU to the internet, and hash include Wi-Fi client.h is used to initiate the connection between ThingSpeak server and the internet through our NodeMCU, and this ThingSpeak library. So how to install this ThingSpeak library? Same, go for sketch, include library, go at the top, go at the top, and you can see manage library again. Click that. Just wait for it. Okay, now the library window is opened. In the search box, you should search as ThingSpeak. Let me do it. Let me do it for you. Let it load. You need to have patience while you're working on the hardware. Without patience, you may burn the NodeMCU modules or you may burn the sensors. So you need to have patience to work in the hardware. It's very necessary for an electrical or electronics engineer. So have patience. Now we got, just search ThingSpeak and press enter. As I said before, there are n number of libraries in this Arduino platform, Arduino cloud. So it may take some time to search the ThingSpeak module for us, ThingSpeak library for us. Okay, meanwhile, the attendance link will be shared in the chat box. Please don't forget to fill the attendance form. So this is just for your information. Now you can see that's a ThingSpeak by official MathWorks. I already installed it. If you are not installed, you will be using first time, right? So click install button and install it again. So this ThingSpeak library is used to initiate the connection from the NodeMCU to the specific channels and API keys. So I will be telling what are those things. So here I declared a constant character and I will be defining my SSD. So in my case, my SSD is, let me see, TIR T-H-H, right? So change it. So it has been changed, and password for my Wi-Fi is, so you need to type your SSID and you need to type your, I already gave the comments for you for the reference here. You can refer to this. So yeah, just check once. It's okay, it's already okay, done. So I am defining pin number before itself. I am defining pin number as, sorry, I am defining pin number as DST pin as 0. So I, instead of 0, I can use this DST pin. So again I am calling the, just a second. So okay, again, and I am calling the DST object here as an DST, and I am giving two arguments. One is 0, that is a pin, and next thing is DST11 because we are using DST11 sensor, and we will be initiating the connection by calling this function called Wi-Fi client, and I am again creating a Wi-Fi client here, client object, and here you can see unsigned long my channel number, right? So instead of this number, go to ThingSpeak, whichever number you got in channel ID, copy that and paste that. Copy it, paste here. Okay. And what is this API key? API key, what is full form of API? API, a full form of API is application program interface. As its name says, it is an interface between some kind of two applications or two hardware two applications or two hardware and software. So this is just an application key. So each channel will have a specific API keys. You should not share this API key with anyone. So this is my write API key. Now we are writing the data, right? So copy it and paste it in the your code. Okay, now I got my API key, and again I am initiating serial.begin as I explained it before, and I am delaying it. And here you should call Wi-Fi.begin, and this is just a normal while loop. It ensures that the Wi-Fi is connected properly. And I am calling ThingSpeak.begin to initiate the connection. And while going to void loop, as you already seen, float h gives the humidity value, float t gives you temperature value, and I am printing it in serial monitor also, and I am giving it 1 second delay. Now here we will be calling ThingSpeak.write field. So this ThingSpeak.write field method gets you 4 arguments. The first argument is the channel number. This is the channel number we have, channel ID. The second argument is the field. As I said, when you click private view, we initiated 2 fields, right? First field is temperature, second field is humidity. So I am writing field number 1, and the third argument is giving as T. T is temperature value, and the fourth argument is the API key. Same thing, my channel number, same channel, but field 2 is humidity, so giving the third argument as H here, and same API key. And I am again delaying it for 100 milliseconds. This delay function takes an argument in terms of milliseconds, not seconds. If it is 1000 milliseconds, it becomes 1 second. So here I am printing as 100 milliseconds. So this is the code. Now I will be connecting my NodeMCU again to the PC, and after that I will be going to tools and selecting the port. Yeah, port is selected. Now before proceeding it further, I will verify the code. It takes time to verify the code. Please be patient. Okay, now you can see the compiling has been done. Now you can successfully upload the code to the NodeMCU. Just click the upload button. Don't forget to fill the attendance form. Meanwhile, you can fill the attendance form when the code is uploaded to the NodeMCU. Okay, now it's writing in the flash memory of NodeMCU. You can see the percentage there. So it's successfully completed. Now open the serial monitor like same. So Wi-Fi is also connected, that while loop, and you can read the data here. Temperature in the room is 27.2 degrees Celsius. Of course, it is not 27 degrees Celsius in the city. We are in the air conditioned room. That's why it's 27 degrees Celsius, and you can just omit these values of minus 13 because of the noise factors and because of some external interference, like the DHT11 sensor is now close to the 50 Hertz power supply, AC power supply. So that's why it's giving some random values. The correct value is 60% humidity and 27.4% degree Celsius, the weather values. Now we will check the values in this platform. Here you can see the temperature is being read as 27 degrees Celsius, and here you can see the temperature rise also 27.2 to 27.4, and you can analyze the data here. So that's what the great advantage of ThingSpeak here. You can see the humidity also is just constant 60%, right? So yeah, it is just reading a constant value field chart. If you want, you can add a widget humidity also, and you can read the humidity value also here. If you want, I can do now. Add widgets, click numeric display, click next, type humidity for field 2, measurement unit is percentage, right? Create it. Now it's reading 61% humidity value. Now it's reading both temperature and humidity. So I am in Vellore city now. I am measuring my room's temperature here, and I am printing it locally using the serial monitor of the Arduino. And at the same time, I am publishing the temperature and humidity values to the cloud, and using the read API key, it can be read. These temperature values can be read all over the world and outside of the world, wherever the internet access is possible. If the planet Neptune or Uranus or Mars has an internet access, you can read my room, this room temperature in Mars or Neptune or Uranus there also, if there is an internet access. Using the read API keys, you can just read it anywhere in the world. These temperature values can be read anywhere in the world. That is the main advantage of IoT. And these all project is completed around rupees 300. Just using 300, this entire project just cost me around rupees 300, and VIT provide me the free license to use ThingSpeak. And the data analytics, see the graph, see the temperature rise 27.7, 27.2 to 27.7. You can analyze it. You can just move the cursor and you can analyze it with respect to time, how the temperature is changing, and how the humidity, as the air conditioner is running, the humidity is being reduced to from 60% to 57%. You can see and analyze the graphs. So this is the power of ThingSpeak. This is the power of MATLab's ThingSpeak, MathWorks ThingSpeak, and this is the power of NodeMCU. This is the power of IoT, Internet of Things. So yeah, we come to the end of the webinar now. We successfully completed the live demo, and I showed you the live output of the thing. And if you want to connect with me, as I said, I am Gokul Krishnan, R&D head, ISTE team 2022. Here is my LinkedIn URL. You can find it in the PPT as well. It will be shared to you soon. You can always connect with me, and you can always ask any doubts, any small doubts, or if you want to discuss some IoT things, or if you want to discuss some electrical things, you can just ping me out in the LinkedIn. And we come to the end. I thank you for one and all attending the webinar and having patience while compiling the program. It just took the long time, I know, and while adding the libraries also, it will be taking time, because we are not working in any software only products. We are working on hardware. So yeah, it should take time. We should have patience. So while compiling the program, don't disconnect the NodeMCUs, like, oh, why it's taking time, so like that. So have patience, compile the program, flash it to the NodeMCU, enjoy the things. I again thank you for one and all attending the session. You can follow our ISTE Facebook handles, Instagram handles, LinkedIn and GitHub also. Thank you. everyone for attending this webinar. Thanks. Thank you. Thanks a lot.